Hey everybody, welcome to our lesson on radicals. We're going to talk about what a radical term is and the different pieces inside. So to start off, if you'll take a look at our radical term here, if you see a number sitting on the shelf on the left-hand side of your radical symbol, that's going to be called the index. And then any number underneath or any variable is called the radicand underneath that little radical symbol. Sometimes called a square root or root symbol also. When you're trying to rewrite a radical expression into exponential form, what you're going to do is you're going to take the index that we just looked at and you're going to put it as the denominator of the fraction power. And that is seen here. This little symbol in between a and 1 over n is the power notation. It's the power symbol, and if you're using a calculator, you can type in that button and it will begin to raise to a power whatever you press next. Here's what it looks like on the screen when you're finished. A to the power of 1 over n. So any number you see as the index is going to become the denominator of the power. And there is no number attached as a power to a in this expression, so we'll use 1 as the numerator. If there were a number in there, we would use that number as the numerator. I'll show you some examples of that to make it easier. So to rewrite again, we have square root of x. That means that there's a 2 on the shelf. Square root of x can be written as x to the 1 over 2. Same thing for cube root of x. That can be written as x to the 1 over 3. Fourth root of x, and you can keep moving down the line and take that index number and use it as the denominator. If there happened to be a number inside as a power already attached to x, let's take a look at that. What we would do is instead of a 1, we would use that 8 that's sitting there, so that could be written as 8x to the 8 over 5. So it's just moving around some numbers to get it into that exponential notation. So let's look at an expression that needs to be simplified and see how we can use exponent notation to do that. Alright, so I've got square root of 8 times the cube root of 8. So it seems like I may not be able to do anything with that, but if you rewrite this into exponent notation, there may be some exponent rules that you can use to simplify this a little bit. So if we rewrite square root of 8, we're going to have 8 to the 1 over 2 because it's a square root, it's the second root. There's an implied 2 on that shelf there for the square root symbol. And then I'm going to multiply by 8 to the 1/3, coming from cube root of 8. Remember, I'm going to take 1 over that number 3. And now, from our exponents lesson, you remember that if we're multiplying same bases, we can add the exponents. So we can now add 1/2 plus 1/3 to get our new power. So let's do that over here to the side. So 1/2 plus 1/3. So we know we need common denominator. We'll use 6. Okay, because both of these, 6 can be divided by both of these numbers. So 1/2 is the same thing as 3/6. And 1/3 is the same thing as 2 over 6. So if we add these, we've got 5 over 6. So that's our new power on 8 here. And if I needed to rewrite this back into radical notation, what I would do is I would take my numerator and I would place it as the power on 8, the radicand, and then I would take my denominator and put it back on the shelf as the index. So we can write this answer either way, either notation that is asked for. All right, let's take a look at another one. A term with some variables in it. So I got the 4th root of xy to the 8th power. So remember, the index number is going to become the denominator, and then any other numbers inside as powers are going to become the numerator. So I've shown you that here. So next step, we would take xy, the product xy, to the 8 over 4. Now we know that we're always going to look out for things to simplify, and we can simplify 8 over 4 to become 2. So that's what we've done in this next step here. And then the last thing we can do is distribute that power to everything in the group. That's one of our exponent rules. So once we've done that, we have x squared y squared, and that's our final answer. All right, last example. We have a little bit of rewriting to do, and then we'll see if anything could simplify when we're done. We always want to check for that. So cube root of 8, let's rewrite. 8 to the 1/3 plus I've got 8 to the, I'm going to take that 4 and make it the top number, the numerator, 4/3 minus 2. Now, if you're using a calculator, you can type in, as I showed you earlier, these bases with the little power key. Here's the power key. And then type in your power. Or you can do a little bit of mental math if you're not able to use a calculator and think about what we should put here. 8 to the 1/3 power, the cube root of 8 means I'm looking for a number that multiplies times itself 3 times to give me 8. That number is 2. Okay? 8 to the 4/3 is a little more tricky. I need to raise 8 to the 4th power and then take the cube root, as I just did with 8. When you do that, when you take a little bit of time to do that, you're going to come up with 16. And then I've got minus 2 at the end. We didn't have to do anything with that one. So I've got 2 plus 16 minus 2 takes us back to 16. Final answer. If any of your radical expressions can ever simplify into regular numbers, you definitely want to test that out and do that so that you can carry your answer all the way to simplest form. So this concludes our lesson on radicals.